example. So let's just say, and this is the sort of question that would be typical of chapter 15. Let's just say that we have a variable x that is representing the lifetime in hours of a type of battery. So how long a battery is going to last, basically. And we're being told that x is a continuous variable with a probability density function given by the rule f of x. And you can see we've got this rule for a cubic function for the domain from 24 to 30, but the function's equal to 0 everywhere else. Okay, so really the bit that we're interested in is just between 24 and 30, which actually tells us that all these batteries last somewhere between 24 hours and 30 hours. Now, the question then says, one of these batteries is chosen at random and tested, and we have to find the probability correct to 3 decimal places that it'll have a lifetime of 28 hours or more, and then less than 27 hours, and between 25 and 26, right? So they're the 3 questions that we're being asked. On the calculator here, I'm just going to run through this, and I've already plugged in the function, which I'm going to first put onto a graph. And I've also kind of set the window on the graph conveniently to show the values that we're going to need. So if I highlight this function and drag it onto my graph, and I've restricted the domain already as well. All right, so this is the function that is representing this variable of the number of hours, or the lifespan in hours of this type of battery. And what will actually happen, and I can show you this in a second, is that the full area between that function and the x-axis should equal 1 because it's representing a probability. And one way we can show that is to use analysis gsolve integral, and the integral with respect to x. And I'm going to put in, as soon as I type a number here, this screen will come up. So I'm going to put my lower value in as 24 and the upper value in as 30. You can see it's shaded the full area, and at the bottom there it's telling me that the integral is equal to 1. Right, so that's just saying that that's representing the full distribution. Now, the probability correct to 3 decimal places that the battery will have a lifetime of 28 hours or more means I actually just want to integrate from 28 to 30. And you can actually just see from looking at it that that's going to be, well, certainly less than half, right? It's going to be a relatively small area, but the area in there is going to tell me the probability. So I can do that 2 ways. I can do it up in the main screen using the integral template. So I'm going to integrate this function from 28 to 30 because that's from 28 to the end or the top of the interval with respect to x. And if I put that on decimal mode because I wanted a decimal place answer, I get 0.111. But I can also show it on the graph by using that analysis gsolve and then integral. And I'm going to type in 28 as my lower value and 30 as my upper value. And this highlighting on the graph is a good way to think of it for what's coming up in chapter 16. All right, now the next part of the question said, what's the probability that we'll have a lifetime of less than 27 hours? So that just means we kind of flip it around and we're going to go from 27 below, right? So it's actually from 24 to 27. Again, you can do it both ways. We can do it with the integral, and that's 0.6875, or we can do it using gsolve on the graph, and both are good for your understanding here. Remember, this is not something that you're going to have to replicate, but it's just trying to help build your understanding for the next section. So if we went from 24 to 27 on this graph, you can see that the area that's been highlighted is 0.6875. And that makes sense because it just, to eyeball it, it looks like it's a bit over half of the area. Right, it looks like approximately 2/3 of the area, and that's about what it is. So what we're saying there is that the probability that a battery chosen out of this sample being tested, the probability that we'll have a lifetime of less than 27 hours is either 0.6875 or 68.75%. So 68.75% of the batteries in this sample have a lifespan of less than 27 hours. That's what that's saying. And for part C, well, we just really are interested in the probability it will last between 25 and 26 hours. So again, you can use the terminals to get that, or you can shade it on the graph. Okay, and that shaded section represents it, and it's 0.275. So, you know, about 27.5% of these batteries will last between 25 and 26 hours.